So it strikes me that to get the 3 Ds that we talked about, to have decarbonised and decentralised grid, we also need a deeply digitalised grid to be able to manage all of these, to be able to kind of provide the pricing or to be able to do microgrids or virtual power plants or any of the other things that we've been talking about. And it also strikes me that probably capacity is not going to be an issue. We're going to be able to solve the capacity thing. The thing that's going to be the problem in a two-way grid where we've gone from, where a lot of stuff happens at high voltage to where it's going to happen at low voltage, and it has to be able to self-heal, and it has to be able to balance at all times, at all moments in time, every single place across the grid. Otherwise, you're going to have blackouts and things. To get that, we need more information. We need deep, radical transparency and the ability to monitor and control what things are happening all the way across the whole energy value chain. And that's going to have that we need some prerequisites for that to all work, for all this stuff to hang together, where it's kind of, on the sort of supply side or the demand side and everything in between. And so at UNSW, we're thinking about, well, what sort of research do we have to do to be able to get to a grid that, from today's grid, to a grid that we'll call a digital grid for all of this stuff to hang together. We said there are 5 prerequisites that we think that we need to solve before we can get to that. Otherwise, it's not going to work in the most efficient and effective way, and might even have some security implications as well, not just cost implications and other things. So the first thing we said we really needed to solve is integrated energy storage, to properly integrate storage at all places along the grid. So at the point of supply, for example, where it's intermittent supply, to then be able to say, well, that's firming storage, for example. And then in the networks and poles and wires, we might need balancing and synchronising kind of storage to kick in. Behind the meter, then you've got customer choices, so you need behind the meter storage for that. And then we need to be thinking about, well, it's not just the kind of battery storage we've been talking about, but we need storage that operates at all sorts of time cycles as well. So from the kind of, microsecond scale all the way through to, in some countries, shifting between, seasonal sorts of storage as well. And so then you're starting to think about, well, what's the role between joining up primary and secondary energy systems? So joining up all these renewables, electricity, for example, with gas. Well, that gives a role for hydrogen, for example, using all of the excess renewables to be able to sort of create hydrogen, and thinking then about how do you integrate that? And then things like pump storage and other sorts of solutions. So what we did is we've done a couple of things at UNSW. One thing is we've just got millions of dollars from partners, including the Australian government, to form an ARC hub in integrated energy storage. That's going to be kicking off in earnest early next year, and it looks at all of those different levels of storage in terms of time, but also in terms of device level through to building level, community level and grid level storage, and says how can we kind of properly integrate those so that this is all going to hang together. The second thing that we just launched last night at UNSW, and Lynn and Sandra came along, is a Digital Grid Futures Institute. So for that digital grid, those things that I talked about, firstly, storage. That second thing that I said that we needed as one of the 5 prerequisites is integrating transport planning and tools with energy planning and tools, because at the moment they're done in silos and they're not really brought together. But at UNSW we've got a fantastic centre for transport innovation with world-class models, and they advise governments and industry, sort of infrastructure developers. But we've also got amazing people thinking about energy and electricity systems. Let's bring those tools together and use them. The third prerequisite I talked about is robust physical connections between all of this. And we're rapidly getting to the point where traditional control systems that are designed for large grids with fewer participants won't be able to do the real-time balancing that we talked about, the synchronisation and the balancing that are happening, let alone be able to do some of those micro virtual power plants when you're deciding, which of these participants do I want to be buying or selling from in my premise at any particular time. So creating the sorts of models and frameworks and tools to be able to enable all of those things is the third prerequisite. The fourth one is having open yet secure cyber connections. And so imagine if everyone's got these virtual power plants, but someone hacks into one of those, creates an instability that can't be solved, and then has sort of roll-on impacts. So and you need kind of that openness to be able to trade with each other or with the grid, but you also need it to be very secure. So creating those sorts of tools as well, let alone all the big data, etc. And then finally, supportive frameworks and policy, regulatory, social and other kind of frameworks to be able to let all this hang together. The other thing, so Lynn invited me here with two hats, the UNSW one, which I've just talked about, but also Watt Watchers. So as the chair of Watt Watchers, Murray mentioned before, we do hardware and data that you put a little device into your meter box. It's an enterprise-grade sort of hardware and data, but at a consumer-grade sort of price. And what I love about it is that it can therefore be... Its comms is very open, so we can kind of do Wi-Fi or 4G or LoRa, which sort of WAN, we're trialling that at the moment. There's lots of different control methods that we can talk to different devices, for example, DRED or Modbus or API. So that means that we can then talk to lots of different things: hot water, storage, solar inverters, air conditioners, electric vehicles, building management systems, etc. And so Watt Watchers is trying to kind of play nicely in everybody else's hardware and software environment to be able to say that we don't want these walled gardens where no one can talk to anyone else's kit. We want to make sure it's as open source and as open and contactable as possible to enable this future. And so I'm pretty excited about what we're doing there. We've got... I think more than 25, Murray can correct me, but more than 25,000 devices, I think, out there in more than 70 different trials in lots of different countries, mostly Australia, thinking about how we serve electricity companies, network companies, individuals, demand response companies who are doing virtual power plants, and energy services companies as well. So I'd like to see more of that sort of innovation to allow all this to happen.